So India is pioneering really. It's not anymore is lagging back behind rest of the world, but it is actually leading the world into these technologies. And the list goes on. So I mean, when we talk about startups, there are a lot of different startup ideas that people come with. So we're going to talk about some of the challenges and of typically an innovative company. If you are doing a commodity hardware like any other hardware, then basically you may be building like an MSME that may be not poised for a large growth and all that. But if you're doing a commodity hardware, there are 100 different companies that are doing commodity hardware also. So you're one among us, them you're sharing the market and all that. But oftentimes when you're coming with new ideas, technology is growing, AI has come, and those many things are there. So you are most likely looking for a product that is first of its kind. Nobody has done it, so you are trying to do. You have a differentiation you're creating. So in those cases, what you do, this is the usual, way that basically you take it. You have to prove your product first of all. So you build a prototype, and then you do a pilot of the product, with beta customers or alpha customers, release some of your products and get some, taste of what the market is like, what is the market acceptance for your product, are people liking your product, and then you really go for the launch is when you do really a first lot of products, maybe 1,000 units or 10,000 units, depending on your, industry segment and all that, and then you will try to scale the company. So these are the kind of companies that we are talking about. Also, when we say hardware, there are a lot of things that will come into picture. It could be, some of those examples that I have given here are basically, if you look at it, these are the kind of companies that I have background in, basically electronics and semiconductors. Of course, even in electronics and semiconductors, we do a lot of mechanical systems and things like that. So we do cover a little bit of mechanical engineering, but some of you from mechanical engineering background looking for a completely different kind of hardware, I may upset you a little bit, but we are looking at, Ahab is actually starting an IoT lab, and with that intent, we want to actually tell you guys, whoever is starting a company, has already started a company, how do you use the facilities of Ahab, and how can you benefit from what is available there and the expertise. So typically, when you are building a manufacturing startup, you would need to look at, some of these things, basically some of these broad level strategies. You need to really look at prototyping. You have to basically smartly build your prototyping. Lot of tools, new tools are available that will help you in prototyping. So you have to prove your concept, because your concept is first of kind, so you need to actually prove the concept. So that is why you're starting from the prototype level rather than, taking some technology transfer and all that. Of course, when you're talking about manufacturing, there are 100 or 1,000 different scenarios. Every company is different. When you make your strategies for your company, you would have to look at a lot of things. So as we go forward, we'll think about it. And then you also have to look at some manufacturing processes. Are you outsourcing your, manufacturing? Are you doing in-house? Those are some of the things. As we go, we'll talk about quality control is very important. When you have basically proven your prototype, and then you go launch the product, the first reviews that will come in from the market, you are watching for the first reviews. If the quality is not good, oftentimes the, your product is not going to scale up immediately, or you may even lose the opportunity to scale up. If the first customer reviews are not good, the chance for you to succeed is not so good. So you need to look at control your quality right from the beginning. The supply chain management, you need to ensure that your, suppliers are also really, scalable along with you. And, scalability, that is basically, you may be able to, you have, let's say, 100 suppliers, and then everybody commits to, 1 lakh volume that you are planning, the next year after you launch your product. And then if all of them can supply, but two or three suppliers cannot supply, then you will not be able to, those are the only suppliers you are depending on, you will not be able to scale up. So those are the strategies what we look at it. And intellectual property, that is also, if you are a deep tech company, obviously you need to have a little bit focus on intellectual property. I mean, if you go to Bangalore or Noida, these kind of cities, I've seen a good, uh, concept about intellectual property. They respect the intellectual properties and all that. but somehow in Telangana and AP, we don't have a good perspective on intellectual property. So put some little bit of your energy and effort to understand, get a right perspective. You will do in-house, how much you do, outsource. So it's a combination can be used. And how, and then when you set up your own manufacturing plant, you need to look at a lot of logistics, lot of different things. You need to have a place for setting up your production, a building, and a lot of capital equipment. And the capital equipment have everything is very engineering, so the precision of the equipments that come into picture. So you need to do a lot of drill down onto it. And are the manufacturing techniques changed for volume production? Usually when you are manufacturing a device or a hardware, when you are doing the prototype, there are certain kind of tooling that you use. And when you are basically building a volume production, you have to use a certain kind of tooling. For the prototype, you probably don't worry about the aesthetics of your hardware, right? Whereas for the volume production, you obviously want your product look good for the other people, feel good, look good. So which means high precision tooling is needed. Some of those things will come into it. And what tech capital equipment you need, that is also you need to look at. And then after prototype, can I do a pilot? Usually the roadmap is that you do a prototype, then go to the pilot. But sometimes if you are not careful, if you don't actually plan ahead, you need to start with the end in the mind, right? You need to understand everything. So oftentimes companies go through one more prototype phase. They have built the prototype and then they're not happy with that. They will one more iteration. What is happening when you do another iteration? In the next slide we'll see. After pilot, can I launch? Again, you did the pilot. When your pilot, the reviews have come back very badly. What do? Then you have to redo a lot of your hardware, and then again, do one more pilot. So which means you're extending your time. So what will be the volumes of our products? That is also basically you need to understand. Only when you know a target volume for each year, third year, what is the volume going to be? Fourth year, what is the volume going to be? Fifth year, what is? On that basis, your revenue projections. So when you are actually doing your worksheets, the actual sheets that you are presenting to the investors, you have to understand some kind of projections, not very too ambitious, at the same time not too low, that you don't get the good return of investments and all that. So a balanced approach need to be. Some of the reasons for companies to fail, hardware companies to fail, specifically what I mean is, badly managed product life cycle. Those are the examples of the pilot, have to be repeated. The prototype has to be repeated. So you need to basically properly manage product life cycle, which comes over experience, but always take an advice of an experienced person so that you don't do those mistakes that normal course you would do the mistakes. Then quality is not good, obviously your customer reviews are not going to be good. Then there is no, you will either miss or lose the opportunity to scale up, obviously. So how do you control the quality? There are different strategies for that. And then not enough funds to run multiple cycles. Some of the hardwares, if you are actually doing a rocket, there is a rocket, you're building a rocket these days, companies are building rockets, or you're building an EV, then these kind of products typically need lot of multiple cycles. One cycle may not be enough. Prototype, you build after the prototype. The first humanoid robot, when it was made, they have done 8 generations of robots. So they have done so many iterations. But these days, it's a time to market is important. You can't do so many iterations. So it is better to plan when you're actually think through the entire process right at the beginning, and then go through it. So unable to scale up, yeah, if you're many regions why you can't scale up. If you can't scale up, you can't reach the success that you want. Lack of product range. A lot of companies actually make only one model of the product, whatever that they're making. Specifically consumer electronics, with one model of the product you can't go, because the consumer mindsets are different. If you want good reviews, you have to have different price range, different feature range, all those. So that is one reason. So your manufacturing should basically consider a wide variety of products, BOMs, and all that. So here is basically the roadmap that we are talking about. So any of these things that we are talking about here, um, the prototype or the pilot, any of these can extend. If it extends, means your cost is increasing, right? If your pilot phase is planned for 9 months or 10 months, let's say, then but it extends to 1.5 year. So you are obviously increasing your cost. Your lot of the costs basically cost, if you know a little bit of cost accounting, you understand what will basically happen. Even if the prototype, you have a target of 1 year to get the prototype out. So what if you do 2 years? You need more funds. You may actually have to go for a bridge loan from the investors. Not very good, right? So those are the things that you would have to look at it. So if you are careful enough, you would actually do certain things in this roadmap that will basically ensure that you are not running around and you will not have sleepless nights. Some of the things that we have put here basically, on the now finances side, you need to basically know when you need actually plant and machinery. So in the prototype and pilot, actually, luckily these days you don't have to go run around. Ahab as basically prototyping and pilot facilities. We'll talk about in further slides how you can use Ahab facilities to make your prototypes and make your pilots go smoothly. Then oftentimes lot of the guys are using, companies are using 3D printing, right? The additive manufacturing. You make a 3D printing. So, but when you make your 3D printing and then basically make your prototype, and you are planning like 10,000 units for your launch, you have to be ready by then with your alternate mechanism for the manufacturing. 3D printing can't scale up. Of course, there's a company in New York that actually hosts like 10,000 uh, 3D printer machines. So if you want like 10,000 units printed, they will actually print in a few days or couple of, in a week or something and give it to you in 3D printing. But you don't have those kind of facilities in India, and it is pointless basically. You would simply have to make your plastics basically, injection molding machines or something like that. So you need to understand those, and you have to be prepared right here. You don't want to wait for your pilot comes up and then you start thinking about manufacturing. So you have to make your molds and all that right here. So lot of it goes basically parallelly. So even though your customer, your marketing team is working on the pilot, getting those reviews about your customers, feedback and all that, and your R&D engineers are basically revising your product, fixing the bugs and all that, you need to look at some focus is there for converting the tools, not only the additive manufacturing. You may have a low need the injection molding. Those of you understand a little bit of mechanicals, the low volume molds are different and the high volume molds are different. So you would have to look at it. We are actually you know ideating a company where we need like 1 lakh plastic containers for the first launch. So we would have to plan accordingly for that basically. Then inventory, once pilot is probably, it depends on your company. You may plan, okay, 10 units I'll release into the market, or maybe 100 units I'll release, or 1,000 units that you release. So that is what you're looking at pilot, where you're basically testing it in the field. Your prototype you tested in the lab, you're testing your pilot in the field basically. So after that your launch. So somewhere here you need to have your finances ready for your inventory also. If you're going to a contract manufacturing house and say, hey, make me these 1,000 PCBs and 1,000 plastics, whatever. So that guy is not going to give you, after I make the product, you after you sell the product, you pay me. He is going to ask you upfront money. So you need to have that money ready. So that means your Excel sheets have to account for that inventory right upfront, right? It's not like a cloud software. You as you pay, as you grow, you keep paying, and you can't basically amortize your costs over a period of time. Here you may need upfront inventory, either whether it is your own inventory that you are procuring, or you are basically outsourcing to a manufacturing plant in Gujarat, let's say. Then that guy is going to ask you, pay me upfront. So for whatever your BOM cost is, bill of material cost is, that money you need to be have ready right here before the launch itself. So that is what the planning that we are talking about. Once your planning is good, then you don't run around. Again, don't start running around to the investor. We need money for inventory. Then you run around the investors. You will probably take 3 months or 6 months to find a right investor to give you that money. By the time your costs, your burn rate is there, the cost is going to increase and all that. So that is what you need to look at it. So right here you plan for that. Then again, when you come to this scale level, you need to look at the suppliers. Let's say your product has 100 parts, and out of the 100 parts, let's say 98 suppliers said, okay, we will supply whenever it is needed, either at your own manufacturing plant or an outsourced manufacturing plant. We'll send you, ship all of them to the manufacturing plant. 98 have them shipped, and 2 of them could not ship, right? For the volumes that you're asking, maybe 10,000 volumes that you're asking. So if they can't ship, your product is not ready. Even if 2 parts are not there, your product is not complete, and you can't ship it, you can't get your money. You have to wait for just these 2 guys, so be able to supply. So you need to have always alternate suppliers, and also do a background study of your supplier, whether he's scalable. If he's an MSME, he may not be able to scale up as you expect. If he's a company that is a big company that can make any, their capacity, production capacity is high, they can supply. So those are the things that you need to look at it. Another thing on the quality, basically you have to use design for manufacturing, DFT. It's more of an engineering term. You need to understand how you basically need to look at the design for manufacturing and design for testing that you need to do. One of the strategies is basically ATE. ATE is automatic test. ATE is automatic testing equipment, and basically what it is, deep technology products you need to actually do. ATE is basically a sophisticated name for a test jig. You need to have test jig in order to understand the performance of your product. So that needs to happen right at the beginning. Okay, that need to actually happen right at the beginning. So oftentimes one mistake that most of the companies do, they make the product, they launch, they do the pilot, so they have the customer reviews, then they say, okay, we are going for the volume manufacturing. When you're going for the volume manufacturing, you need to test. Let's say you have 10,000 units, you have to put software into every one of them. If you do it manually, it is going to be very time consuming and also expensive. It has to happen automatically. And we'll talk about what is ATE a little bit more, because we have a little additional time. So the ATE needs to be proved, just like your prototype, your product needs to be proven. The ATE needs to be proven, and it needs to be matured. So the product maturity time that you have to have it for ATE also. So that is why you need to start the ATE right here. You need to start right here. Don't wait till you are just before launching. If you start here, you will take more time, and the launch is going to extend. If the launch is extending, again the same problem. Your cost will increase, return on investments will reduce, everything that you need to basically backward. And at AHA we have basically an IoT lab that is coming up, which has test and instrumentation, PCB fabrication, 3D printing, PCB population. This is what one of the new things. I don't think anywhere else in Vizag they have. So here basically you can get your prototype, even your pilot. Let's say if you have 100 units, you can actually make it here. You don't have to run around to Gujarat or Bangalore, etc. You make your PCBs your own cost. All you need to, you are not putting any capital equipment yourself. You're saving a lot of crores of money there, and simply rely on AHUB. Make your basically PCBs there, starting from the bare PCB to population. So I mean there would be certain limitations, but for most products this will definitely work, and you can actually make your you know yeah, that will all, that slide will come, yeah. So this is the for the prototype and pilot. So next thing that we have is basically we are going to have a test initiative in AHUB. Again, this is first of kind we're basically doing here. Lot of them are buying the instruments, but and lot of, like I said, lot of them miss out on the volume. When you are scale up, you need to be ready with your ATE. Your test jigs need to be ready by then. They need to be mature. That means your ATE work usually starts maybe a quarter after you start your product development. Immediately you need to start, as you are developing your product, you need to develop your test jigs also. Otherwise, because the test jigs need to be proven, that test jig is a software and hardware again, so there are bugs going to be there, it needs to be matured. So by the time you have scale up your ATE, you have to have additional resources doing that. So what we are doing at AHUB is basically a IoT lab with a lot of these ATE equipments and ATE related software that will help you create your own ATE. If you don't know how to build the ATE, I do have some experience in ATE, a lot of experience actually, matter of fact, in ATE, and we will try and support you basically as a company. And then, and then get your ATE, help you how do you actually build your ATE, so that you can actually scale up uh, in prescribed time. What is an ATE? If you don't have heard of ATE, if you haven't heard of ATE, it's very simple. It has basically a PC, and that will have a automatic test suite that will run. It may take half an hour to run all the tests. Like a motherboard, you are testing so many tests that need to be done. These are all the instruments that are going to be in NAHub. They're all network connected. Basically, the PCB will control all these equipment. Those will be connected to the PCB intern, and the PC it will test the PCB. When you actually test a PCB, you have to see maybe a dozen points and see the voltages and currents flowing through, or maybe sometimes even 50 or 100 points. See the performance of the PCB. It's not just, oftentimes people assume that you assemble a board, a PCB, and test it, it will work. Oftentimes that may not be true. It may work for 1 month, 2 months, 3 months, and the electronics actually deteriorate over a period of time. So what this ATE, just I'm not going very deep technical, but you will have, let's say, 1.2 volts is what is expected. You can tolerate 1.15. 1.1, if the voltage becomes 1.1, it doesn't work anymore. So over a period of time, it can degrade. And also, not all components that are coming from the semiconductor industry are all same. Basically, there will be some variations, a little bit of 20-30 millivolts. So you may set, okay, 1.15 is my limit, it's okay. But over a period of time, when you are actually launching your product and you realize there are a lot of defects that are coming. So when the defects are coming, you will actually trace down to a single voltage somewhere in the problem. Then the only way that you can do is tell your manufacturer, okay, limit all those units to 1.17 volts. Unless you have an OTE, this kind of quality control you cannot do. And the problem is really simple. All you need to do is actually maybe replace a resistor, which in the manufacturing plant it is very easy. Once it goes to the customer, the cost is going to be high. And sometimes, a lot of the electronics like gadgets and all, one time, I mean, if it doesn't work, you'll throw out and buy. But everybody, you can't do that same thing with an EV. You have to kind of, uh, you know, have some kind of mechanism to repair a lot of electronics, consumer electronics, things like that. So you need to look at that aspect of it. That is the reason that you need ATE, and we'll support you from hub, in your ATE strategy. And a lot of additional strategies you need to, if you are selling to Europe and all that, you have to take care of ROHS compliance and all that, environmental testing. You have to do a lot of testing. If your product is going outdoor, you need to do water testing, those kind of certifications. You need to plan tools. Use sophisticated, a lot of low cost tools are available these days for ERP or CAD and all that. Even open source SkyCAD, a lot of, like, any of you use those kind of things. And then another thing that you need to do is do good business models with your partners. Basically, either you're talking to your, contract manufacturer, he may ask for a net 30 or a net, sorry, you may ask for a net 30. Some of them may, like the product, they may give you, but upfront costs are there. So you look at some good business models where your contract manufacturer may take some of your financial risk, maybe. And then also with your suppliers, basically, you talk with your suppliers net 30 terms, that you will pay 30 days after they deliver. Some suppliers definitely do those kind of terms. And seamless integration, if you are outsourcing, you still need to be on top of it. You can't simply say, I have given all that, I have given him the money, he's going to give the boards back. You have to basically set up your test systems. And especially you have multiple BOMs, multi-level BOMs, bill of materials. You need to basically on top of things, that he is making the right model that you are asking, but not some other model. So those are the things, important things. Imports and exports, the, whether you are doing it in China, for example, there is a company called Boat. All their manufacturing happens in China. I mean, they're planning to move it to India, but they're able to do it. So the import costs, export costs, you need to have alternate suppliers in your supply chain strategies, logistics, warranty, how much warranty. You may have a moving parts, motors and all that. So you need to look at your warranty schemes, repairs and maintenance. How do you repair and maintenance? All this before your launch and before you scale up, you need to have all these standards. Material standards, that is another thing that you need to look at it. And then of course you have to have demand forecasting. Basically, you may plan for 10,000 units. Is your marketing team and your product gets sold like 10,000 units in that year, or you may be only doing 5,000. So you have to carefully quarterly demand forecast and properly plan your production and all that. These are the things that you need to be ready for. And if you plan things right, you will actually avoid delays, you will avoid recalls and your sleepless nights. That is one thing that you can do. I'm done with that. Any questions?
Now you can pose your questions if you have any. Open. You are free to ask questions.
How does the manufacturing process? Okay,
Yeah, sure.
because no, I worked in both manufacturing and IT. But how do you relate an IT project to manufacturing? Because you've been on both sides.
Yeah.
So early preparation for testing, test plans, test cases, and all that stuff.
Yeah.
How does that relate to the
Yeah,
manufacturing?
that is basically what we have said right in the beginning. The first slide was that basically what we are saying in a typical software project, e-commerce project, and all. These are the different IT hardware guy is always running around quality, funds, and suppliers. Funds means you have capital equipment, plant and machinery, which is not there in case of an IT. You can always hire a cloud infrastructure as you are scaling up. As you are scaling up, your cost will grow, either from Amazon and all that. That is going to be very different. Your financial planning has to, irrespective of whether you're selling 10,000 units or 1 million units, you need to have your capital equipment planned for a certain capacity. That is one of the things that you do. Suppliers, like 100 suppliers, out of the 198 suppliers, 2 did not supply, your product will not be out. There you go. So you got to be alternate suppliers. These are the things that in a software you may refactor your software, and then quickly next night you can release the patches, but that's not possible here. You're dependent on suppliers, your partners. You need to carefully choose your partners, enable your partners, educate them, coordinate a lot with that. And quality, of course, like ATE, these kind of things will help in your quality. Of course, quality is there also, but here you're talking additional quality. Not only your cloud software, your hardware also need to have quality, necessary things for that ATE you need to build. Yeah.
Again, one context in the IT parlance, you give a product which has got bugs, and if they don't identify within warranty period, you make money out of the bugs that you created.
Yeah.
Not possible in manufacturing.
Yeah, of course, that's what the last slide said. Basically, if you look at Ola, basically Ola is basically their front fork is problem, right? So here in the hardware you may have recalls. Recalls are very expensive, you have to fix it on your own. Ola is fixing all their front forks, maybe a design problem, material problem, whatever it is. I mean, there is internal problem, so you avoid your recalls. That is the reason you are actually scaling up your volume gradually. As you have 1,000 units, you will have to try and see reduce your number. At least you make sure your hardware will not be replaced. As long as you're replacing the software in your IoT, no problem, that you can always cost effectively without much cost you can do. But you want to at any cost avoid your recalls. Either you need to first avoid replacing a complete subsystem, then replacing parts. So as your basically volume grows, you will actually from a subsystem replacement to part replacement. Part replacement easier, it is still expensive, you have to do it on your own or whatever. And basically that is one thing. The recalls, try to avoid recalls, they are expensive.
The migration from version, okay, different versions, because product upgradation happens.
Yeah, okay.
So there are some of the components which will go to the next product version.
Yeah.
But some we will have to exhaust. So how do you do that migration back?
Yeah, it is a little more involved engineering exercise, but your product life cycle management, you need to have proper product life cycle management. Usually you will have multi-level BOMs, basically a BOM under which you have multiple subsystem BOMs. So chances are you have multiple models. Basically some subsystems are common, the wireless system may be there, so you maintain multi-level BOMs, keep track of them, what is your inventory and all that. And a seamless integration with your outsourced manufacturer is important, basically. Hopefully you're not miscommunicating, so wrong model comes out. That's not really good. Of course it doesn't have. Yeah, exactly. Yeah, yeah, of course, that is where your design smartness is there, so that you'll ensure most components are common components. That way your inventory is high on those common components, you will actually negotiate at a better price with their more volume. So unified design needs to be doing. So yeah. Yeah.
You have a
Yeah,
question?
sir. Yeah, I would actually recommend go for an e-commerce for the reason that is easier. But that's a, oftentimes it happens by passion. Somebody has a passion for hardware. Why not? I mean, there is also requirement for hardware in the country, right? Hardware needs to be made, and often these days they're all trying to do it everything in India. So it all depends on what their vision is. If they are neutral, they're agnostic to software or hardware, then e-commerce is easier. I don't recommend go for hardware. It needs a lot of expertise, like what we talked about, manufacturing and all that. And it is easier to do a software startup than a hardware from a easiness perspective. But from your willingness, your focus, your vision, your idea may need a hardware and a software also, depending on what idea you're pursuing. You need to look at this.
How do you, because you are into smart kitchen manufacturing
Yeah,
now,
okay.
right?
Yeah,
So how do you overcome the China dependency? I know it's not completely resolved,
right. Yeah,
but in case something, COVID, we had a problem.
yeah, right.
So any strategies there?
Yeah, see, China dependency is going to be there. Lot of the robotics for our equipment that we are doing, the motors are being manufactured in India. Lot of the motors we can customize, manufacture. Lot of these companies, and the sensors, the electronic components is still we need to depend on Asian countries. So, but the semiconductor supply chain is very bad right now. Last few years, the components are not available, but there are strategies in which you can actually get these components, and all that components are available if you go through the proper distributors. They are supplying for the prototypes. We are looking at 3 years from now, we are basically looking at the launch. So by that time we need to have these volume strategies. But lot of the our product is perhaps 20% electronics, 80% mechanical products, like the grinders and all these things that are there. Like there are 14 subsystems that are there, multi-level BOMs. The difficult thing for ours is actually three-tier manufacturing. We are actually looking at somewhere around 2000 to 3000 components, parts that are being in the system, which will come from 14 different main suppliers. They will have suppliers. How do we have all this that is the biggest problem than the R&D.
So tier one, tier two.
Yeah, tier 1, tier 2 is there, the main assembly plant, and then tier 2 and tier 3. That is what I'm talking about. So
You're planning
just
going for an ERP or
yeah, we are doing the ERP right from the beginning. Yeah,
PLM?
PLM also. There was open source software called Odoo, so we started using. Odoo is really good. I mean, we don't have to put the big SAPs and all that.
But after specific time limit, then you'll have to start paying, right?
Now what we got is basically 2 modules are free, perpetually free. 2 So with those two, I think those are the two